Okay, guys, let us continue our discussion of the graphs of quadratic function. Okay, so this time we have this as our objective. At the end of this video, I hope you are able to identify the vertex of the quadratic function. And also you're able to describe the behavior of the graph of quadratic function defined as the product of a and the square of the difference of x and h plus k with vertex h 0 where a is equal to 1. Now if the vertex of the function is at h 0, then we consider this form um, f of x is equal to the product of a and the square of the difference of x and h in our discussion. Okay, let's start. Okay, now let us try to observe the behavior of the graph of the quadratic function defined as the product of a and the square of the difference of x and h, where a is equal to 1. So let us take this function equals x squared as our reference function and its corresponding graph as our reference graph. Now, so what do you think is the value of h here in this quadratic function? Okay, so looking at the formula, you cannot find an h here or any other number. So therefore, the value of our h is 0. Now, how about the value of k? Now, again, let's look at this formula. Then this has, there is only x squared. Nothing can be seen um, from here. So therefore, k is also equal to 0. Now, what about its vertex? What is now its vertex? Now, its vertex is at the origin with coordinates 0 and 0. Okay, so we have here this graph. So again, let's consider this as our reference function and this as our reference graph. Now let's take this example. Quadratic function defined as the square of the difference of x and 1. Now, looking at the formula, can you identify the value of h? Okay, what do you think is the value of h? Is it positive 1 or negative 1? Okay, let's find out. Okay, now this function, this quadratic function, can be written as the square of the difference of x and positive 1. No? Okay, so instead of x, the square of the difference of x and 1, we can also write this as the square of the difference of x and positive 1. So what is now the value of our h? Okay, so the value of our h now is positive 1. Okay, how about our k? What's the value of k? So again, so our formula is only this. Okay, there is no k in this formula. So therefore, k is equal to 0. Therefore, what is its vertex? The vertex has the coordinates h and k. So therefore, the vertex is at the point with coordinates 1 and 0. No? Now, as you can see, we are able to identify the value of h, the value of k, and the vertex of the quadratic function, even if we have not yet graphed the function and we have not yet um, seen the table of values of the given function. Now, let us continue with the table of functions. I mean, table of values. Okay. If x is positive 1, the value of the function is 0. So we have this point. If x is 0 and positive 2, the value of the function is the same, positive 1. And these are the points. If x is equal to negative 1 and positive 3, the value of the function is the same, 4. Okay, so let's look at the graph. Now, let us observe. Now, do you think the two graphs are identical? Okay, so let us find that out if the two graphs are identical. Okay, yes, no? So, since the two graph overlap each other, then the two graph is identical, and that um, the graph of the quadratic function square of the difference of x and 1 is translated one unit to the right. Okay, so you see that. Okay, okay, so let's have another example. So this time we have here a quadratic function defined as the square of the difference of x and 2. So can you identify the value of h and the value of k and its vertex? Okay, again, now this formula can be written as, okay, instead of the square of the difference of x and 2, we can also write this formula as the square of the difference of x and positive 2. No? Okay. Now, what's now the value of h? Of its h. Okay. So h is equal to positive 2. Okay. How about the value of k? Again, k is 0. And the vertex of this quadratic function is at what point, or which point? Okay, correct. So the value is, the vertex of the function is at a point with coordinates positive 2 and 0. Okay, so again, even if without looking at the graph, we have not yet graphed the function or drawn the graph of the function, and we have not yet seen its table of values, we are able to identify the h, k, and its vertex. Let's continue. As x takes 2 as its value, then the value of the function is 0. Okay. So if x is equal to positive 1 and positive 3, the value of the function is the same, positive 1. If x is 0 and positive 4, the value of the function is again the same. We have positive 4. So let's look at the graph. Okay. Then again, look at the graph. Are they identical? Okay, we can only say that they are identical if the two overlaps. Okay, so let's look at here. Yes, okay. So the two curves are identical, only that the graph of the quadratic function, the square of the difference of x and 2 is translated 2 units to the right. What do you think is the reason, or which do you think is the value from here is um, the reason why our graph is translated 2 units to the right. Okay, let's continue. Okay, here is our third example. In our third example, we have here the quadratic function defined as the square of the sum of x and 1. Okay, can you identify now the value of h, k, and its vertex? Okay, what's h? Okay, let us see if you are correct. Okay, now this formula can be written, this formula square of the sum of x and 1 can be written as the square of the difference of x and negative 1. Again, here the quadratic function is defined as the square of the sum of x and 1, which can be written as the square of the difference of x and negative 1. So therefore, the value of our h is, okay, correct, negative 1. How about k? K is equal to 0. And its vertex now is at the point with coordinates negative 1 and 0. Again, we have not yet seen the graph of this function, and we have not yet seen the table of its values, but we are able to identify the vertex. Okay, let's continue. If x is equal to negative 1, the value of the function is 0, and that is this point. If x is equal to negative 2 and 0, the value of the function is 1. So here are the points. If your x is equal to negative 3 and positive 1, then the value of the function is the same again, which is 4. And these are the points. So let's look at the graph. Okay. So again, the graph is identical to the reference graph of x squared. So let us again see. Yes, okay. The same graph, only translated 1 unit to the left. Okay, 1 unit to the left. Why do you think to the left? Okay. Which value here is related to its motion, which is moved from the origin to this 1 unit to the left. Okay, so here is our fourth example. Okay, the quadratic function is defined as the square of the sum of x and 2. Okay, so what is now our h and k? Okay, so again, this formula can be written as the square of the difference of x and negative 2. So therefore, the value of our h is negative 2 and the value of our k is 0. Now, the quadratic function has the vertex at the point where has the vertex with coordinate negative 2 and 0. So let's look at the graph. Okay, so again, let's look at here. Okay, so identical graph translated 2 units to the left. Again, what do you think is the reason why our graph is translated 2 units to the left? Okay, we have already four examples. So let us now try to summarize what we have discussed. Here is our reference function, and here is our reference graph. Okay, it has vertex at the origin. So Here is our first example. Now, with vertex at the point with coordinates positive 1 and 0. So let's look at how the graph behaves. Okay, the graph is translated 1 unit to the right. In our example 2, the vertex is at the point where with coordinates positive 2 and 0. And let's look at how the graph behaves. Okay, so the graph is translated 2 units to the right. Okay, in our third example, we have the vertex at the point with coordinates negative 1 and 0. And the graph is translated 1 unit to the left. For our fourth example, the vertex is at the point with coordinates negative 2 and 0. And the graph behaves this way. Okay, so it is translated 2 units to the left. Okay, so we have observed clearly how the graphs of the quadratic function defined as the square of the difference of x